This is a recorded session to revise for your quiz next week. Okay, recording started. Your quiz is going to be about the electron configuration, the how to find the elements in the periodic table, and all these kind of information. So before you begin your quiz, the first very thing that you do next to your periodic table or on your scratch paper, I want you to write the diagram that we use for the electron configuration. So 1, 2, 3, 4, 5, 6, and 7. S all the way. Now some students, they prefer to follow the periodic table, that's fine. But just to be on the safe side, I want you as well to have this one, this diagram. So it will take you less than a minute to write it. So on the first level, from the first level, S sublevel starts. From the second sublevel, P starts. From the third sublevel, D starts. And 5 and 6. And from the fourth level, F starts. So 4F and 5F. And then after, you draw parallel arrows headed downward. Okay, please note that in the periodic table, here's the group 1 and the group 2, and then again like this. So this area is for the S1, and this is S2. Okay, I'm just writing it here, S1, whatever it is, and this is S2. And now, when D starts, it's over here, the D. And the first D is a 3D, then 4D, then 5D, then 6D. Not to forget this one. And eventually, last, here's the area of P. So here's P1, P2, P3, P4, P5, P6. This is S2. Okay, so I hope that this is clear. F is at the bottom. Here we have 4F and we have 5F. So this is the 4F line, and this is the 5F line. Of course, in the D, the first is D1, D2 up to D10. Okay? Now, part of your quiz is going to be about the electron configuration rules, following the 3 rules in order to fill the to distribute the electrons. And I'm going to mention these rules briefly. We have off-bow principle. We have Pauli exclusion principle, and we have the Hund's rule. By simply writing this diagram and following it, you are obeying and you are applying off-bow principle. And off-bow principle states that upon distributing the electrons will fill the orbitals from lower to higher energy. You do not skip an orbital before, you do not move to a next orbital before filling the previous one completely. And I mean by this, an S can contain 2 electrons. You do not start with the 2s unless 1s is full. You do not start with the 2p unless the 2s is filled with 2 electrons. Now p has 6 electrons. If I don't put 6 here, I can't move to the 3s. If I don't have 2 here, I can't move to the 3p, and so on. So keep in mind, S can maximum hold 2 electrons, P can maximum hold 6, D can maximum hold 10, and F can maximum hold 14, sorry. F can maximum hold 14. So, Aufbau principle, electron fill the orbitals from lower to higher energy. You cannot skip until the previous one is full. Now, I have questions to show you exactly what do I mean by Aufbau principle. Like, for example, I have 1s and I have 2s. I cannot put one electron here and another electron here. No, I have to finish from the 1s. Once done, then I move to the 2s. The Pauli exclusion principle, it states that every orbital, every box, can maximum hold 2 electrons. In a way, those electrons having opposite spins. So if I am in S, the electrons has to be like this. If I am in P, you cannot just put P like that. The electrons has to be in opposite directions. Even if you are in D, maximum of 2 electrons, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, Hund's rule states that when you are filling the orbitals, you must fill the orbitals singly and then double the electrons. So it is wrong to do like this. 1, 2, 3, 4. That's incorrect. I should always fill the P in this way. 1, 2, 3, then 4. Or this is correct. Now let's look at D. If I am filling a D orbital, it is wrong to put the D like this. I have here 6 electrons. That's completely wrong. I should fill the D in this way. So if I have 6 electrons, 1, 2, 3, 4, 5, 6. This is the correct one, following Hund's rule. So now let's start with some questions related to your quiz next week. Now, which of the below is the correct configuration of P? The first thing you do is you go and look for P in the periodic table. Find P in the periodic table. And it shows that P has 15 electrons. 15 electrons. And when you look at the periodic table, you will see P in the P block over here. So here's the boron, carbon, nitrogen, oxygen, F and E, and there's P below. So P is in, this is only line 1, 2, line 3. It ends in 3p3. And there's also here 3s2. So this is the end of the electron configuration of P. Or I can simply count and see which of those contain 15 electrons. So 1s2, 2s2. So I'm comparing all the answers to see which one is the right one. 1s2, 2s2, 2p6. So far these are 10 electrons. 3s2, 12 electrons. I need 3 electrons. This is wrong, this is correct, this is wrong, and this is wrong. So this is the correct answer. Now, another question about the rules. Which rule is violated? The rules that we spoke about, that I mentioned on the previous page. Now, first, when you look at a question like this, first find the mistake. So first, find the mistake, and then think about the rule. Then think which rule. And you have to memorize the names of the rule, the name of the rules. This is a must. So here, when I look at this diagram, this is wrong. This is the same mistake repeated. Now this is violating the Pauli exclusion principle, since Pauli said you cannot put two electrons with the same spin. So this violates Pauli exclusion principle. Violated. Now let's look at the second diagram. Again, here's the mistake. Off-bow, I can check 1s, 2s, 2p. They're going in the correct order. And there's a mistake here. Again, this mistake is violating Pauli exclusion principle. Please, in your quiz, do not just write Pauli. Write the full name of the rule. Moving on. Here's another diagram. You look at the mistake in the diagram. So, I'm checking off-bow, 1s, 2s, 2p. The order is correct. 1s is full, 2s is full, 2p. Let's see. They left this empty, and this orbital has double electron. So this is wrong. And this violates Hund's rule. Hund's rule said that you cannot double the electrons before you finish filling them singly. So here I have 3 electrons. Those 3 electrons must go like that. 1, 2, 3. Not 3 like this. So here's the violation, violating Hund's rule. Moving on, the next diagram. Let's look at it and see where's the mistake. So this is obviously 2p, this is obviously 2s, and there's definitely 1s behind, but they're not showing it. The 2s is incomplete. And then they started filling the 2p. So this means the rule violated here is off-bow principle, because we jumped to fill the orbitals of p without completing the 2s. Off-bow principle. I hope that my explanation is clear. Again, this is the same rule violated over here. We started filling in the 2p while this one is incomplete. So I cannot start filling the 2p and the previous one, the 2s, is not fully loaded with electrons. So again, here we are violating off-bow principle. Okay. Before I move on to the next question, I would like to point at the below. You have to know the name of each one. Electron configuration, noble gas notation, orbital diagram, and Lewis dot structure or Lewis dot diagram. Let me just give some space here. Lewis dot structure or Lewis dot diagram. What's the difference between them? So let's say we are dealing with phosphorus, the one I gave up in the first question. The electron configuration of phosphorus would be 1s2, 2s2, 2p6, 3s2, 3p3. Writing it in this way is called an electron configuration. Now, substituting this part with Ne and then continuing 3s2, 3p3, this is called a noble gas notation, which means you choose a noble gas from the periodic table instead of writing all this part. Ne is equal to 10 electrons, and we continue with the rest. Orbital diagram, it means you need to draw the orbitals. You need to draw the 1s2. You need to draw the 2s2, to draw the 2p6, and so on. So here's the first one, 1s2, done. Here's the second one, 2s2, done. Here's the 2p6. You have to draw every orbital the correct way. So p has 6 electrons. I'm done with 2p6. And now again, 3s2. And there's no space. I'm going to do it down. 3p3. 1, 2, 3. Any way drawing 3p3 other than this, it would be considered wrong. Okay? Now, Lewis dot diagram is when you only look at P and draw the dots, place the dots around the symbol of phosphorus, and the dots would be the valence electrons. The valence electrons. So, I can know the valence electron from the electron configuration if I don't want to look at it in the periodic table. So the highest level reached is 3. I have 2 electrons in S and 3 electrons in P. That means a total of 5 valence electrons. Or I can simply go to the periodic table and see where is P, and it is going to be, like the one I did here, P is going to be in group 1, 2, 3, 13, 14, 15. Group 15. So group 15 means 5 valence electrons, or like here, 5 valence electrons. So when you do the symbol, when you draw the symbol, you must put 5 dots around it. Okay, now going back to the questions, write the correct Lewis structure or Lewis dot for SR, AL, P, and K. P, we just did it. Phosphorus, 1, 2, 3, 4, and 5. For strontium, for aluminium, and for potassium, find them in the periodic table. In the periodic table and see which group. So strontium belongs to group 2. So it means it has 2 valence electrons. So I need to put 2 electrons around strontium. Aluminium is found in group 13. So it should be, I'm just going to show you here the periodic table. So here's strontium, it belongs to group 2. Here's aluminium, it belongs to group 13. Here's potassium, it belongs to group 1. So aluminium group 13, that means 3 valence electrons. And potassium belongs to group 1, 1 valence electron. So again, this belongs to group 15, 5 dots. This belongs to group 1, 1 dot, 1 valence electron. This belongs to group 13, 3 dots. And this belongs to group 2, 2 dots. That's how we do it. Now, if ever an orbital diagram is given to you, how would you know which element is this, or how many valence electrons you have, which group it belongs, which block it is it a metal or a non-metal? You have a very simple way. Just count the electrons and find out which element is this. So 1, 2, 3, 4, 5, 6, 7. 7 electrons. If I go to the periodic table, 7 electrons goes for nitrogen. So that is nitrogen. And nitrogen belongs to group 15. It has 5 valence electrons. It's a non-metal, in case they asked about this. It's in the P block side. So let's see what do they want in the question. Here, they are asking you about the valence electrons. How many valence electrons? 5 valence electrons. Or I can also look at the highest level reached. 2s and 2p, highest level reached in this orbital diagram, and we have 1, 2, 3, 4, 5 valence electrons. There are many ways to get the answer. So you choose the one that suits you. Which group it belongs? 5 valence electrons, it means group 15. So that's it. You answered the question. Now moving on to a next question. For each of the given, find the corresponding element. If you look here, all these elements are in the D block. The D block. So I need to count for each one and find out. You count to be on the safe side, because if there is an exception, looking at D5 won't help you. Looking at D10 won't help you. You will miss the 4s1. So you need to total. So 2, 4, 10, up till here, all the configurations have 10 electrons so far. Now let's continue. 12, 18. Up till here, all the configurations, they have 18 electrons. Now these two, 20. Up till here, 20 electrons. Now, for this one, 28 electrons. For this one, 26 electrons. For this one, 18, 19, 24. I have a total of 24 electrons. And over here, I have 18, 19, 29 electrons. And now we go to the periodic table. Who's the 28 electrons? The 28 electrons is nickel. The 26 electrons, iron, belongs to iron. The 24 electrons is an exception for the electron configuration rules. It's chromium. It's more stable configuration to remove one electron from the 4s and place it in the 3d5 to have a half-filled orbital, much stable, more stable, and a Cu copper 29. So here it is. This is more stable to move one electron from the s and place it in the d. This is an exception to the octet rule. So as you can see, the safest way is to count total how many electrons and find them in the periodic table. Now, noble gas notation of silicon. Silicon has 14 electrons. I can double check that in the periodic table. Now, which noble gas suits silicon? Argon has 18 electrons, neon 10, helium 2, neon 10. So this is so far, very far, and this is more than the 14 electrons that we have. So these two options are not correct. Now, am I going to take the Ne3s2 3p2 or the Ne3s2 3p5? Let's count. 10 plus 2 plus 2, and for this one, 10 plus 2 plus 5. That's 17 electrons. That's 14 electrons. This is the correct answer because silicon has 14. Or if I go to the periodic table, silicon is on 2p, is on 3p2. 1, 2, 3, 3p1, 3p2. Okay, so again, since this is a revision for your quiz, it is very important that you know how to explain and the difference in the principles that we follow when we are doing the electron configuration. So the Aufbau principle states that when filling the orbitals with electrons, you have to be clear in your explanation, okay? It says explain, so you explain it properly. So when filling the orbitals with electrons, we must start from lower to higher energy levels. Once the sub-level is completely full, we move to the next one. You can also explain the Aufbau principle in a different way and say that when filling the orbitals, we follow this order. And when filling the orbitals, we follow this order. And you mention 1s2, 2s2, 2p6, or you just say 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, etc. This is another way to explain Aufbau principle. So I have to follow this order. Pauli exclusion principle. How do you explain the Pauli exclusion principle? Pauli exclusion principle states that you cannot put more than 2 electrons in one orbital. A maximum of 2 electrons in the same orbital. And I will just mention this. If I have P or D, let's say I have D. Okay, the box is the orbital. So I cannot have in an orbital more than 2 electrons. The maximum is 2 electrons in the one box. Okay, and when you are placing those 2 electrons in the same orbital, they must have opposite spin. So a maximum of 2 orbital in the same orbital, maximum of 2 electrons in the same orbital having opposite spins. Hund's rule, when filling a sub-level with electrons, and I mean here a P or D or F, electrons must be filled singly, then double them. Or you memorize the definition of Hund's rule in your notes. So if I am filling P singly, then double. If I am filling D single electrons, then double. If I am filling F 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. So single electrons, then you double the electrons. You do not double at start. So I hope that this is clear. Now, another question. Write the configuration of chromium and of copper. Be careful. These are exceptions. Exceptions. So, chromium, 24 electrons, and copper, 29 electrons. Chromium will have 4s1, 3d5, and copper will have 4s2, 3d10. The question will not mention it. You have to pay attention to it. So it doesn't say noble gas notation. It doesn't say orbital notation. It says electron configuration. So for both of them, for Cr and for Cu, I have a 1s2, 2s2, 2p6, 3s2, 3p6, and here's the change that you have to pay attention to it. Chromium will have 4s1, 3d5. Do not write 4s2, 3d4 and then put the other one. خلاص, just directly 4s1, 3d5, and this one 4s1, 3d10. Full stop. That's it. Without mentioning anything. Now, another question. When you have an electron configuration given to you, and you have to use the electron configuration to identify some information about the element. So, always count, and count to be on the safe side. So, 2 plus 2 plus 6 plus 2 plus 6 plus 2 plus 10. That's 30 so far. 5. So the total is 35 electrons. 35 electrons. Count. That's the safest way. Now, which element is having 35 electrons? That's bromine. Bromine. Now, it says in the question, name. I know that you know the difference between name and symbol, but do not write your answer like this, bromine, Br. No. I want you to clearly show me that you know the difference between a name and a symbol. And the question didn't ask for the symbol. Don't put the symbol. So you just write bromine. That's the name. Now write the noble gas notation of this element. In the periodic table, the last noble gas before Br, the last noble gas before Br is the argon, 18 electrons. So on the configuration, on this configuration, these are 18 electrons. So I cancel them, I erase them, and I write instead argon. Argon, and then I continue with the rest, which is 4s2, 3d10, 4p5. So again, instead of all of this, you write Ar, because this is equal to 18 electrons. Now, which group the bromine? It's in group 17. When we check the periodic table, it's in group 17. In case they ask about the valence electron, it has 7 valence electrons. Which period? The highest period reached is 4. Or in the periodic table, 1, 2, 3, 4th line. 4th line. And the line in the periodic table is called period. Now, Lewis dot diagram. The dot represents the valence electrons. So 7 valence electrons. Now we put the symbol with 7 dots around. What is the type of this element? It's a non-metal. Being in the P to the right side of the periodic table, it's a non-metal. Now, the last question for this session is when you have, here's an example, you have a periodic table and there are questions about this periodic table to select from it. So, first, when you get a question like this, write the groups 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, group 13, 14, 15, 16, 17, 18. Now, here's the stairs. So everything before the stairs are metals. After are non-metals. Non-metals. Okay, I'm gonna highlight it just to make sure that my table is clear. So I did not highlight V. It is a non-metal actually. So the yellow, the non-metals, I'll write that in a minute. The blue are the metals. I did not highlight the first box in here. The blue are the metals. The green are the metalloids. So non-metals, metals, metalloids. Now, this is an S block element and this is an S block element. Okay. All this area is dedicated for, it's called S block, D block, P block without the V, P block, and F block. Let's start with the questions. Give me an element from group 16, W. An element that has an electron configuration 1s2, 2s2, 2p6, that's 10 electrons, 12, 13 electrons. 13 electrons, that's gonna be Q. An element in the F block, you can say Z and D or D. So here it says elements, so name them all. So everything in the D block, in the F block are Z and D. In the D block, oh, we have plenty. N, U, X, and E. On here, D finishes. Okay. An element that can be found in the 4th level. Okay. Let's change to black color. 4th level. That's the 4th level. That's period 4. An element found in the 4th energy level. You cannot choose from the D. Yani you can say only your answer is R. Okay, here there is nothing in the table written. 4th level S. I cannot select N or X because N is in the 3D and X is in the 3D. So this is an element right now in the 3D. So I take the R in the 4th energy level. Okay? An element that has orbital notation of 1s2, 2s2, 2p6, 3s2, 3p1. So you can count 2, 4, 10, 12, 13 electrons. Where can I find 13 electrons? Again, this is Q. And that's it.